What would happen if we could modify human DNA at will? A possibility like that wouldn't just alter our biology, it would mean rewriting evolution itself, no longer a blind process, but one guided by human intent. When Gattaca was released in 1997, audiences were introduced to a future where children were no longer conceived, they were designed. A world where your destiny was written in your DNA, where society was stratified between the invalid, the natural, and the valid, selected and optimized in laboratories. In that future, genetics didn't just define health, it defined your place in the world. For a long time, this idea remained confined to science fiction, until we learned how to read the code of life itself. A code made of just 4 letters, A, T, C, and G, the alphabet that writes every living organism on Earth. For decades, science worked to read it, to understand it. Today, we can modify it. We can change a single letter, insert a new one, or rewrite an entire segment of the genome, programming exactly where the intervention happens. The cutting edge of genetic engineering is CRISPR, clustered, regularly interspaced short palindromic repeats. The most powerful biological technology humanity has ever discovered, derived from the immune defense system of bacteria against viruses. Bacteria store fragments of viral DNA inside their own genome, and when the virus returns, a guide RNA, a molecular GPS, directs the Cas9 protein to the precise point where the DNA should be cut. A molecular pair of scissors, faster, cheaper, and more precise than anything that came before. And this is the part that still genuinely amazes me. We're talking about a technology that truly allows us to rewrite the human species, a power sitting at the center of our future, and yet barely discussed. This is the same technology at the core of a secretive startup founded in San Francisco, Preventive. CRISPR opens the door to what's now being called high-performing, the shift from treating and preventing disease to enhancement, not removing pathological mutations, but designing traits that improve performance. Higher intelligence, lower anxiety risk, faster metabolism, greater height, eye color selection. Not a cure, a biological upgrade, the so-called designer babies. And here I want to be very clear. On this channel, you won't find moral panic, alarmism, or prepackaged opinions about scientific or technological progress. That's not who I am, and that's not what I want to build here. I study these technologies, I follow them closely, and I'm deeply fascinated by what they make possible. My approach is neutral, rational, but fully engaged. Not to judge, not to demonize, but to understand and to tell the story. Because the tools we are discussing today are among the most transformative humanity has ever held. And what still surprised me most is how little we talk about them compared to the scale of their impact. Publicly, Preventive talks about monogenic diseases, conditions caused by a single gene, like sickle cell anemia or cystic fibrosis. But then comes the most discussed tool, polygenic risk scores. Unlike single gene disorders, many diseases and many complex traits like height or intelligence are influenced by hundreds or thousands of genetic variants, each with a tiny effect. Polygenic scores aggregate all these micro-influences into a single estimate. Not a diagnosis, a statistical prediction. They allow scientists to estimate for each embryo the relative probability of developing certain diseases or expressing certain traits. Many startups frame this as a question of freedom of choice. From this perspective, gene editing is simply an extension of decisions we already make through IVF, because a form of selection already exists. With IVF, embryos are selected based on the absence of certain anomalies or a higher probability of developing properly. The real debate happens at the boundary. Where does pathology end and where does trait begin? And to what extent should parental choice be considered a right when informed by data and enabled by technology? In 2018, the most explosive case in the history of designer babies emerged. Chinese scientist He Jiankui announced the birth of twin girls whose DNA had been edited with CRISPR to confer resistance to HIV. The goal was to replicate a naturally occurring mutation, CCR5 delta 32, found in a small percentage of the population and associated with reduced viral entry into cells. The important point was the edit was performed at the embryonic level, on germline cells, which means the change doesn't stop with the individual, it becomes heritable. Once introduced, that modification enters the human gene pool. There's also the technical challenge of off-target effects, unintended edits elsewhere in the genome, a problem research is still actively working to minimize. Despite recent attention on preventive, this isn't Sam Altman's first biotech investment. He previously backed Minicircle, a company focused on gene therapies for longevity and performance, including protocols that increase follistatin production, a protein associated with muscle growth and fat reduction. Minicircle doesn't operate in the United States. It operates in Prospera, a private experimental city on the island of Ratan in Honduras. Prospera is a special economic zone, a startup city with ultra-low taxes and an autonomous legal framework, a hub for frontier clinics, investors, and radical experimentation. A governance model designed to challenge the conventional idea of the state. Projects that would take years to approve in the US can be tested here now, including human enhancement protocols and transhumanist interfaces like subdermal biometric microchips. Minicircle openly states that its therapies are investigational, not FDA approved, and are administered in international clinics operating within alternative regulatory ecosystems. Preventive, reportedly, is exploring similarly permissive jurisdictions, including the UAE, to conduct experimental phases offshore, possibly reaching a point where the first genetically modified child is announced after the fact. So here we are, at a frontier where two truths coexist. On one side, one of the most extraordinary technological advances in human history, the potential to reduce disease, extend health, even imagine humans adapted to entirely new environments. On the other, real questions about access, inequality, and power. Important questions, but often asked as if our society were already fair, inclusive, and equal, as if progress were threatening a utopia that has never existed. We talk as if gene editing might create discrimination, but discrimination already exists, deeply, structurally, everywhere. Technology doesn't invent it. At most, it makes something that has always existed more visible. So the real question isn't whether these tools will create an unjust society. The question is, will we use this power to genuinely improve the human condition? Or will we simply replicate the same hierarchies with more advanced tools? Because the point isn't to fear progress. The point is to recognize that we are the progress, with everything that implies.